Hello viewers, welcome to today's session. We're going to look at assembly language programming, where I'll introduce you to one of the programs. I'm Kiberenge John, welcome. So let's look at how to write a program to exchange the contents of a memory location, and these memory locations are found at address 2000H and 4000H. As we discussed earlier, in order to write a good program, you either need to write a program algorithm, which are statements that indicate the program sequence, or you can also write a flowchart, which is a diagram that indicates law. So if you are to write a program on this transfer, switching between two memories, the algorithm will be like: number one, the first step, to get the contents of memory location 2000 into the accumulator. Then you have to save the contents into register B. So why should you get the contents from the memory into the accumulator instead of transferring directly from memory to memory? It's because in the 8085 processor, there is no operation that does a memory to memory transfer. So all data in the memory must be passed through the accumulator if you are to take it to the register. So after saving the contents into, say, a register B, we get the contents of memory location 400 into the accumulator. Then we store the contents of the accumulator into our address 2000, followed by our fifth step, which we get the contents of register B into the accumulator. Then step 6, we would save the accumulator contents to address 4000 and terminate the program. Looking close at this program, we see that first we have moved what was in 2000 into register B, and therefore we can erase whatever was in address 2000 because we have a copy of it in register B. We'll need to move 4000 memory content into the accumulator and take the same content into memory 2000. That would be our program algorithm. If we are to draw a flowchart, we'll have to start, that is the symbol, followed by getting the memory to accumulator, then move accumulator to register, then get the second memory location into accumulator, now I'm using this connection because my page is full and I have to link it to the next page to continue with drawing the flowchart. So the next step would be to store what is in the accumulator, that is what we got from the second memory, into first memory. Then we get what was in the register to accumulator and take it to the first memory. We take it to the second memory, then we end the program. So here we see we have effectively swapped what was in memory 1 into memory 2, and what was in memory 2, we brought it to the first memory. Now to write the program in assembly language, we have our program algorithm, which we have stated earlier. Here it is. For each number, for each step we associate it with a mnemonic, which is our assembly language. So in order to get the contents of memory location 2000 into the accumulator, we use the instruction LDA 2000H, which will load the accumulator with contents that is in memory 2000. Then next we said we save the contents into register B, and therefore we use the instruction that moves data within the registers, that is move to register B, contents of the accumulator. Next we get the contents of memory location 4000 into the accumulator. You see here at step 2, we have what was in memory 2000, we brought it into the accumulator and taken it into register B. So we have a copy of contents that were in 2000. So step 3, we are moving what is in our second memory 4000, we bring it to the accumulator, and that command we use LDA 4000H. Because our memory is in hexa, we must put that H. What is now in the accumulator is the content of memory 4000. We can store it directly into memory address 2000H. Now we have what was in 4000 placed in 2000. Now we need to place what was in 2000, we need to place it in memory 4000. And that brings the step in which we are supposed to get the saved content that was in register B back into register A. And we use the command MOV, which is move into the accumulator contents of register B. Now our content is in the register, we store it directly into address 4000. And by doing that, we've managed to switch the data bits. Not forgetting, we have to end the program and we say halt. There are many ways of killing a rat, and therefore this program is not unique on itself. We can write an alternative program. We can develop an algorithm for it. So an alternative program would be to initialize HL register pair so that we have the HL register pointing to our memory location 2000H. Then the next step would be to initialize register pair D and E so that D and E are pointers to our memory 4000. So we have two pointers here, H and L pointing to 2000 and D and E pointing to memory 4000H. The next step would be to get the contents of this memory 2000 into register B. Then we get contents of memory 4000 into the accumulator with the help of the pointers that we have already initialized. Therefore, we'll have contents of 2000 in register B and contents of 4000H in register A. So we need to take A into 2000 and we need to take B into 4000. So we store the contents of accumulator into memory location 2000, and we copy the contents of A into the accumulator. Why? Because we cannot move data, we cannot copy data directly from register B into the memory. So we have to bring what is in register B into the accumulator and then store it into memory location 4000. After doing that, we end our program execution. So for each of these algorithm, we have to match it with its mnemonic. So for the first one, in order to initialize HL register pair to point to this memory location, we have to use LXIH 4000. Load register pair H and L with immediate data, and our immediate data is 2000H. Here it is data, but later on it will be a pointer. We are providing the address. Next, we want to load that address 4000H into register D and E, and we use LXI D4000H. We said when you see this X, you know that the data that follows is to be taken to a register pair, and it is a 16-bit data, 48-bit, 00, another 8-bit, and therefore we use the load command. Next algorithm is get contents into memory location 2000, move that into register B, and we use move into B M. Now our M here refers to what is in register HL, and we've already programmed HL. We've initialized it to point to memory 2000. Therefore, we are moving into register B contents of 2000 H memory address. Then we get the content of 4000H into register A. We have to use LDAX D. So we are loading the accumulator with the pointer that is in register D, and register D, as you see in our second step, we've initialized D and E to point to 4000H address, and therefore what is in 4000H is brought into the accumulator. We need to take that content to memory location 2000, and therefore we use move M. Our M is in H and L, which is 2000, and therefore we move to memory address 2000, contents of the accumulator. So we've completed the first step. The next step is to move what is in register B to the accumulator and take it to memory 4000. We use move into accumulator what is in B, and we store using the command *x D. So we store what is in the accumulator using the address pointed to by register D and E. Finally, we terminate our program using HLT, which means halt the program, and execution would stop. So this is an alternative program for performing a switch of contents into register 2000 and register 4000. And these are not just special register, it can be any, not special memories, it can be any memory, provided you write the correct memory address. Thank you so much. Stay safe. Feel free to ask any questions.